Zeal Education Society, redefining excellence.
Hello friends, my name is Chinmay Deshpande. I am from Department of Electrical Engineering, belongs to Zeal College of Engineering and Research, Nare, Pune. In this video lecture, we are going to discuss about reversal of a direction of rotation of a DC motor. Now, we know that the DC motor can turn in either direction. That is, it can be turned in a clockwise or it can be turned in an anti-clockwise direction. But obvious, we can control this direction by changing the polarity of a applied voltage. Now, let's see this diagram. Here we are going to apply our Fleming's left hand rule. Why to apply Fleming's left hand rule? This is because here we are going to use DC motor. Now you know that what is a Fleming's left hand rule. So this is my left hand. This will be your F, this is B, and this is your I. F is the force, B is the magnetic field, and I is the current. So please try to apply this left hand rule to this figure. Now the direction of a magnetic field is from north to south pole. So this will be your B. So direction is downward. So therefore here we have we will keep our position of a finger in this way. Then force, here that force will be at which direction? The force will be at this direction. So direction will be like this. So this is your force. If you try to apply, you will see this. This is a force. This will be your, what we can say, direction of a flux or the field. And now if you observe this finger indicates a current. So if you apply Fleming's left hand rule in this way to this particular figure, then you will observe that the current is going inside the screen. The current is going inside. So therefore the direction of a current is pointing towards the computer screen. So always remember that this cross is nothing but inside, or we can say that inside the screen. Now how to change the force so that this wire travels in the opposite direction, causing our motor to rotate in the reverse? Now what to do here? Now here again we have to apply a Fleming's left hand rule. Now what I did, here the direction of a field is same, that is from north to south, that is from upward to downward. So F, B, I. So this B will be like this. Now this thumb denotes your force. So it will be in right hand side direction from the screen point of view. And whatever this finger is there, this finger, middle finger, denotes the direction of a current. So here you will observe that the current is coming outside, that is outside the screen. So therefore, if you observe these two diagrams carefully, here we can change the direction of a current. How? By changing here, or we can say that by changing the force, we can change the direction of a current. And whenever the direction of a current is to be changed, then but obvious, the motor will rotate either in clockwise direction or anti-clockwise direction. Now how to make this? In order to make the motor to rotate in the clockwise direction, we must reverse the flow of a current. That is, changing the flow of a current, which in turn changes the direction of the force by exactly 180-degree opposite. So how to do this? Of course, the direction of the current can be controlled by the polarity of the voltage. So therefore, if I want to change the direction of a current, if I want to change the rotation of a DC motor, I need to change the polarity, or I need to reverse the voltage. So because of reversing the voltage, because of reversing the polarity, the direction of the current will be opposite and the rotation of a rotor will be in opposite direction, because here the force will be applied exactly in opposite direction, that is 180-degree to that of a previous one. Now it can be seen from this figure also. So here we have taken 4 cases. We know that cross indicates that inward current, dot indicates that outward current. Now here please observe this first figure. This is your north pole, this will be south pole. Always the direction of a field of a lines is from north pole to south pole. Now here this is what is a cross, and here the force is given towards right hand side. So please try to apply again Fleming's left hand rule. So if we apply here, now this will be your field, this is a field, then force will be like this, Now here what you will observe, if I stretch this finger, then I will observe that the direction of a current is inward. The direction of a current is inward. Now if you see this second case, that is case number B, what we did? Just we change the direction of a force. How to change the direction of a force? Here by changing the polarity. Because if we change the polarity, the direction of a current is also reverse. So here you will observe that the current is coming outside. Here I have not changed the direction of magnetic field, that is which will be from north to south. Just I have changed the force. So by changing the force, or we can say that by changing the voltage, we can change here direction of a current. Now if you observe this C, now here north pole will be in upward and south pole is a downward. So this is what is the case. Now here if you observe, so this will be the case for case C. This is a force. Now what is this? This will be your direction of a current which will be inside the screen. So therefore this is your inside current. Now what is to be changed here? Now just it should be seen like this. This is what is a force. Now the direction of a field north to south as it is. Now by changing the force here, you will observe that the current will be in outside, or current will be outside the screen. So therefore if the direction of a main field in which the current carrying conductor is placed is reverse, then the force which will be experienced by the conductor is also reverse. So let's see the two cases. Case this is A and case this is C. Now here you will observe that in case A the field will be from downward to upward. For case C, here will be from upward to downward. So here if we change the direction of a field, then also we can reverse the direction of a force here. Now in case of case B and case D, again in case B it will be in upward direction, that is magnetic field or magnetic lines, whereas here the magnetic lines will be in downward direction in a case D. So again here you will be able to change the direction of a force. But in both the cases, that is B and D, it indicates dot, and dot is nothing but outward. So similarly, by keeping the main flux direction constant or unchanged, the direction of a current which will be passing through the conductor is also reversed. So here you will observe the case A and case B. Here we have changed the direction of a current so that your force will be different here. So these are the four cases with the help of which we can easily understand the reversal of a direction of a rotation of DC motor. But if you observe, if we try to change both, that is the main field and whatever your current direction is there, if you try to change these both, then the direction of a force which will be experienced will remain same, and there will be no change in the direction. Now therefore in a practical motor, to reverse the direction of a rotation, either the direction of a main field produced by the field winding is reversed, or the direction of a current which will be passing through the armature is reversed. The direction of a main field can be reversed by changing the direction of a current which will be passed through the field winding. We know that whatever field which will generated in the main field, it is because of the current only, that is the current which flows through the field winding. So if we change the direction of a field winding current, then but obvious we can change the direction of a main field, which is possible by interchanging the polarities of the supply which is to be given to the field winding. Now let's see this diagram here. Now this F1 and F2 is nothing but field winding connections. A2 and A1 is nothing but your armature connections. Now either the field terminals are reversed or the armature terminals are reversed. So here this F1 and F2 we can reverse it. Here F1 is connected to positive, F2 is connected to negative. So if I connect this F1 to negative and F2 to positive, the direction can also be reversed. Or in other words, we have to change this direction of a current in an armature. That is, here A2 is connected to positive, A1 is connected to negative. So by changing A2 or by connecting A2 to this negative and by connecting this A1 to positive also, we can reverse the direction of a motor. Now this is what is a very simple diagram which will be self-explanatory. Forward direction, reverse direction, and here again reverse direction. There are two methods for the reverse direction. So by changing the supply polarity in the field winding or the field supply, that is here the field terminal consists of but obvious F1 and F2. Normally in a forward direction, the DC supply, this is plus minus DC supply, will be given such as F1 will be positive. So let's say this will be F1, this will be F2. So positive is given to this, so it will be positive. Negative terminal to this F2 is connected. So therefore here to change the direction of the polarity, it should be reversed. That is F1 should be connected to negative and F2 should be connected to positive. Then by changing the polarity of a armature winding. Now how to change the polarity of armature winding? Now here you will see this will be your field terminal, this will be your armature terminal. So therefore now here if you see minus plus we have written, this is a field terminal, and here we have written plus minus. So by armature terminal consists of A1 and A2. Normally for the forward direction, the DC supply will be given in such a way that A1 is connected to positive and A2 will be connected to negative. If you want to change the direction of a polarity or of the direction of the motor, then the polarity should be, that is A1 should be negative and A2 should be positive. So in this way you can reverse the direction of a rotation of a DC motor. Thank you.
Zeal Education Society, redefining excellence.